The strength of acid and its concentration have vital roles in various fields. What do we mean by the strength of an acid or base? Does it represent the concentration of acid or base present in a given amount of solution? Or does it represent the nature of the acid or base? The term concentrated indicates that more moles of acid than normal are dissolved in a given volume of solution. The term dilute indicates there are fewer moles of acid in a given volume of solution. The concentration of the solution depends on the level of acid or base in solution. The term strong indicates complete ionization. The term weak indicates incomplete dissociation. The strength of the solution depends on the nature of the acid or basic solution. When acid dissolves in water, it gives H+ ions. Example: hydrochloric acid gives H+ ions and Cl- ions. When base dissolves in water, it gives OH- ions. Example: sodium hydroxide solution gives OH- ions and Na+ ions. The strength of an acid or a base depends on its degree of ionization in water. Strong acids and bases completely ionize in water. Example: sulfuric acid is a strong acid since it ionizes completely. Sodium hydroxide is a strong base since it ionizes completely. Weak acids and bases partly ionize in water. Examples: acetic acid and ammonium hydroxide. Observe the animation given here for a while and click on the Ready button to answer the question. To find out the amount of H+ ions or OH- ions, we need a universal indicator. Sorensen, a Danish chemist, introduced the concept of the pH scale in 1909. P in pH represents Potenz, power in German, and H stands for H+ ions. The pH scale ranges from 0 to 14. pH equals 0 represents a very acidic condition. pH equaling 14 represents a very alkaline solution. The pH value of a neutral solution is 7. The pH values of various substances are shown here. pH is measured by a pH paper or a pH meter. pH paper is prepared by impregnating filter paper in universal indicator and drying it. For preliminary pH measurements, pH indicators are used. For precise and continuous measurements, a pH meter is preferred. pH is expressed by a mathematical notation as the negative logarithm of molar concentration of dissolved hydrogen ions. We can calculate the pH of 0.1 molar concentration of hydrochloric acid as shown here. living organisms can survive in a narrow pH range between 7.0 and 7.8. When the pH of rainwater is less than 5.6, it is called acid rain. This low pH kills most aquatic life. Some plants grow better in alkaline soil and some grow best in neutral soil. Rotten roots produce acids in soil. If they are not removed, the soil becomes acidic, unfit for the cultivation of most plants. Sometimes acidity is neutralized by adding alkaline salts to the soil. We digest our food with hydrochloric acid produced by the stomach. If the same acid is produced in excess, it affects the gastric layer and causes ulcers. The acidic pH is reduced by taking an antacid, which contains bases such as aluminium hydroxide or magnesium hydroxide. Our teeth are coated with an enamel of calcium phosphate. Our saliva maintains the pH of our mouth in the alkaline range. Food particles sticking to the teeth are usually attacked by bacteria, so that the pH level in the mouth falls. The acid produced by bacterial action attacks the enamel and results in tooth cavities. The alkalinity of toothpaste neutralizes the acidity produced by bacterial decay. The acidic pH range supports bacterial action in milk. So in dairies, milk is treated not to allow the pH to fall below 6.6. Certain biochemical reactions occur at some fixed pH values in industries such as breweries and food processing units. Clinical laboratories regularly test the pH values of blood, urine, etc. to diagnose certain diseases. pH values are very important in cosmetic products such as shampoos, face creams, soaps, deodorants. Insects use pH as a defense mechanism through what is actually chemical warfare. The sting of a wasp contains a base that causes irritation and pain to the person stung. Can we neutralize the basic pH by applying an acidic solution? Yes, we can apply lemon because it contains citric acid. When ants bite us, formic acid enters the skin and causes itching. We can apply calamine, a solution of zinc carbonate, to the affected region to reduce the itching. The plant nettle has very fine hairs that contain methanoic acid. When we accidentally touch the leaf, it injects this acid into the skin and causes irritation. This irritation can be reduced by rubbing with baking soda paste or soap or a dock leaf.